Hey everybody, welcome to another extra help session with Mr. Leeson. That's me. Again, I'm so proud that you guys are here to try to get a little extra help and to push your boundaries in terms of what you think you can and can't do, because you can always do when you believe you can, right? So we're going to look at constructing functions from 2 points, and that is something we looked at the other day, and we had some successes and some confusions here and there, and we're going to try to build upon those successes and try to see if we can kind of clear up anything that's making us confused, so we can have more success moving forward. Okay, so our objective here is that we're going to be able to determine the rate of change and the initial value of a function from two xy values. So specifically, we've been looking at linear functions, which linear is derived from that word line, right? So we're looking at situations that are lines, and they have, if you notice, lines don't do a lot of ziggle-zaggles. They kind of just keep doing what they were doing. So they have a rate of change that's constant, right? So from this point over to this point, from here to here, the rate of change is the same as the rate of change over here. And if we know the rate of change, we can plot points that are outside of what we've already taken into account. Also, initial value kind of gives you like sort of maybe a starting point for where to apply this rate of change, right? So, and the initial value is the y-intercept, right? That's the y-intercept, and that means that x is 0 at that initial value point. So y-intercept, so here's our y-axis. Every line that isn't a vertical line, that's not on the y-axis, so maybe my y-axis is over here. Every line that's not a vertical line will cross the y-axis at some point, and that can be a place where we can apply the slope or the rate of change and start building our line. You can build a line from any point as long as you know at least one point on that line and a slope, which is pretty cool. Anyway, so what is slope? We said that is the rate of change. That's how much the y values are changing. The y values are changing as we move along the x-axis. As we change our x value, how much is the y changing, right? That's our slope. And change, we're finding a difference, right? So in this case, we can use y sub 2 minus y sub 1, and this is kind of the sort of the formal formula for finding slope when we have 2 points. And that's y sub 2 minus y sub 1 over, or divided by, x sub 2 minus x sub 1. So the change in y, how much y is changing over the change in x, and that's going to give you a number, and that'll basically mean y goes up by 4 every one move here, right? And left or right on the graph here. But as we look here, we have a change of 2. In this particular example, y has gone up by 2 when x has changed by 1. So in this case, this graph shows a slope of 2. That's the change in y over the change in x. All right, so we take a look at a real world example here, and we're not in a fantasy world because and you may not know, I'm a multi-platinum recording artist in the genre of string brass Latin jazz fusion, right? And so I have a YouTube account that I've been running for 5 years, and so far I have 200 likes, 200 streams over the last 5 years, and I've made $3 from YouTube these past 5 years. I'm pretty proud of that. And then, but I was looking, a couple years ago. I was, oh yeah, I wrote in my journal, and I said, man, I got 100 songs. I've been downloaded 100 times. I've been viewed 100 times. And that day I got a check for $1.50, right? That's pretty awesome, right? So basically what I was curious about was how much exactly is YouTube paying me for every song, every time one of my songs is downloaded, right? Every time one of my songs is streamed on YouTube. And you know what? That's possible with the information we have here. Uh, and just real quick, we do have a linear relationship between the songs and the dollars here, right? And if we remember from the other day, if you see dollars in a linear situation, or when we're talking about a function, that's almost 99.9999999 times 9% guaranteed to be a Y value. That's an output usually, right? You put some effort in, you get rewarded with some money, right? So I put some effort in, I recorded this song, I put it up on YouTube, and I got a reward or an output of money, right? So this is my output. So these must be my inputs, right? Or my independent variables, right? Input, independent. That's pretty easy to remember that. And then these right here are my dependents, right? So Yoda, right? Yodes, right? So independent, and this is my X. That's my X value, right? So X, independent, Y, dependent, Y, output, right? Independent input, right? So those are some ways to maybe think about that. Change in Y. So these are my Ys. How much did Y change between these two values? It looks like it changed. We have 3 minus $1.50, right? So $3 minus $1.50, that's going to give me a change of 1.5, right? And then I'm going to put yep. And then 200 is my independent here when I had $3. So I'm going to keep that going. That's my Y, my X sub 2 that goes with that X sub 1 there. So I've got 200, and then I'm going to subtract to find how X changed. And it changed by, it looks like 100. So I got a change of $1.50 between those 100 additional downloads, between 100 and 200 there. So what is my cost, my income per song there? How much is it costing YouTube every time one of my songs is uploaded or is played, right? So I'm going to divide by 100. That's divide by 10, divide by 100, take my decimal, put a 0 in there. So I get paid a whopping 0.15 dollars per song. And that, I know that 0.01, that's 1 cent, 1 penny. So I get paid 1.5 cents every time my song is downloaded or played or up, well, I don't even remember the term anymore, on YouTube, right? So I get paid at 1.5 cents every time my song is played, right? So, which sounds like chump change, right? But if I aspire to get, you know, 1 million plays by the end of the, you know, my lifetime, and that might add up, right? Because I have to multiply this 1.5 cents times 1 million, and that'll give me some change, right? So that'll give me some money. All right, so slope in this case, that was how many dollars I was getting per one song, right? So let's look at this other example here. So now I'm trying to save some of my money because I want to be able to retire at some point, right? I want to try to save money. So I just started saving, and my balance in my account after 1 month, and month, that's a time word, and 99.99999% of the time is going to be an independent variable, or X, just heads up there. That's going to be an X value, right? Because things change over time, right? And then the balance in my account is $80. And then, like we said, dollars, 99.99% of the time, are dependent variables, right? Or outputs or Y's, right? So that's That's going to be my output. That's going to be my yod, right? Yoda. And this is going to be my independent or my input, right? After 3 months, look at that, another time, right? So that's going to be another input value. I'm going to call that x sub 2. And then of saving the same amount each month in the account is now has $120 total in it. I've got $120 now. After 3 months of saving, I have $120. That's another y value. So I'm going to call that y sub 2. It's associated with this 3 months. So it says, how could you represent this situation as a linear function written in slope-intercept form? So slope, that's m, right? And intercept, the variable there is b, right? So slope-intercept, that's a special configuration here where I have y equals m x plus b, right? So I have some y values, I have some x values. I don't really see my m and I don't really see my b, but they're kind of hidden in this situation here. So again, how do I find slope? You guys know that we can find slope by finding the change in y over the change in x. In this case, it's a change in the amount of money over time, right? So how much time is represented in this situation? So I have 3 months minus 1 month. So it looks like maybe this has been 2 months in the making here, right? Between these two values here. So the change in y, how much did y change over that time? So my y sub 2 that goes with my x sub 2 here is 120. And I will subtract 80 because that is the amount that goes with that 1 month. So I'm going to get 40. I have $40 that I've saved over the 2 months that I'm looking at here, right? So that's $20. So m equals 20. Nice. It's good to know. So 20. And now to get this in slope-intercept form, I still need to find my b. So handy dandy thing here, I just use the information that I have. I have some x and y values that I can put in, that I can substitute in to make this work, right? So I have a 120 over here, and that goes along with this 3 over here. So if I can plug that in, substitute those numbers in for the y and the x, I can solve for b after I isolate b, right? Isolate that variable. Oh, I forgot to get my x into, oh, I forgot to substitute. So we're going to substitute. So that 20 is actually being multiplied by 3 and then being added to the initial value to get my 120 here. So 120 equals $60 plus b, my initial value, and I subtract 60 from both sides to isolate that variable, and I'll have $60 is b. $60 was my initial value that I had in my savings account before I started saving anything up here. So our final answer here, which we're going to write this in slope-intercept form, right? Y equals 20x, because we saved $20 per month, and then we added that to our initial value to get our current y value. And this is useful information because now I know if I want to know how long it's going to take to save up to maybe $1,000, I can just plug in 1,000 here for the y and then solve for my x, that's the number of months, and I'll know how long I need to wait, how long I need to keep saving in order to get to this $1,000. And you can go the other way around, right? So it's like, wow, what if I was saving for 10 months? How much money would I have after 10 months? And just real quick, this will be my last thing I'll do here. So after 10 months of savings, how much money will I have? So I'm going to do 20 times 10, and then add 60 to that, and that's going to give me a number of dollars there, right? So y equals 20 times 10, that's 200 plus 60. So after 10 months of savings, I will have $260. And from there, you might be able to figure out how many more months do I need to save to get to my target goal, right? So after 10 months of savings, I'll be up to 260. Cool. All right, so look at that. So we were able to translate all of this information into a simple formula that we can use to make predictions about the future and to help us plan for the future, right? So in that way, these sorts of formulas can be pretty useful for our everyday lives and for whatever line of work we might go into when we're older. All right, so thanks for the time that you've taken out of your day to help yourself get better at math. And let me know if you have any questions, comments, concerns, interesting thoughts. I'm open and ready to hear them. All right, take it easy, guys. All right, see you later.